And I started my session with, I have decided to not occupy 100% of my session slot with content for me. So therefore I would like to ask you to think about questions regarding data access or management in the context of Xbase++, for which we will have 15 minutes by the end of my session. So because in the past always we talked about what we think, so maybe we should talk about some questions on your side at least. Unfortunately, even though I thought my session is too short, I just couldn't get this idea because I needed more time. So I'm trying to prove that I'm being able to learn, which means I will repeat. Please start to think a little bit about your questions regarding data access or data management in general you want to ask me, let's say in 1 hour and 10 minutes from now. So you can prepare yourself if my session is not interesting to you by thinking about what are the questions you want to have covered. Another point is at 12:45 there will be a photo session. I think it's in front of this building.
Yes.
Okay. So I don't need to explain, but still 12:45 photo session in front of this building. Those which don't want to be on the photo can stay with me here.
You're not going to be in the photo?
I'm kidding.
Of course you're going to be in the photo.
It's not fair. Okay. 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 Database workshop. It's about data access, data management. I also want to talk a little bit about application architecture. Also about application architecture in the context of 2.0. So I decided to have 3 areas in my presentation. First one is just a review about performance aspects of application, means of which type of data access, deployment, or database management system are used. Then I want to talk a little bit about coding patterns, what you want to do, and about application architecture, and finally about your issues you can start to think about. And if you don't like, we can have a lot of coffee to make us feel better. Let's go to this.
A group podcast.
So, what's this? It's clear when I have a local file on my local hard disk and I perform insert update operation on this local disk on my local machine, I'm the fastest. I mean, I can do 25,000 updates or appends on my laptop if the file is opened exclusive, if I'm the only user on this local machine on my local hard disk. When it comes to a remote file, it's getting worse. It's clear because it's no more local, so it's coming from the network over a remote data source. There's a bandwidth restriction, there's latency coming into the game. It needs more time. It's clear it's not as fast as the local file. But then it starts to get confusing because we have a dramatic decrease of performance the more clients are coming into the game. So the question is, what's the reason for that? And for this, maybe something to write. Generally, when we have the fix it. Okay. Dangerous equipment.
Yeah.
Generally, let's assume we have a table. When I update one record on that table, the pattern in the multi-user scenario is very simple. There's the arrow, there's our replace, and there's the DBR unlock operation in a simplified way. So, because we're in a multi-user scenario, we are sharing the table, we need to perform the lock, perform the update, and do the unlock. What's happening in reality behind this? A little bit more. The first thing what's happened when I do rlock is it performs the lock of the record, which means the record on hard disk is locked. Now the workstation can gain write access to the record. Other workstations can get read access to this record. No problem. Next step is read of record. That means at the same point in time when you perform rlock in your application, the record gets explicitly rereaded from hard disk on the server side on the file. Any cache, anything gets flushed, it's explicit, this record gets moved from hard disk into your main memory again after the lock. And this is required to have a guarantee that you are updating the record as it is at a point in time when you acquire the lock. Then you perform the update operation, which is basically a operation inside memory. There are some semantical checks, it's the proper data type, proper lengths, and so on, but nothing more. The replace does not go to hard disk. And then there's the DBR lock, or unlock. The DBR unlock performs 3 steps. Or 2 steps, but in the first step, it initiates it's called a client commit. Initiates a client commit operation and initiates the unlock. The client commit is a composite operation of write, which means the memory update gets written to disk, and the flush. The flush means the local cache buffers get cleaned up, so it's ensured the data is sent over to the remote server. It's not ensured that this data is on the remote server persistent on hard disk. It's just ensuring in this implicit commit pattern that the data is moved away from your client station. When you want to have maximum data safeness or reliability and minimum performance, just add a db commit here, because this db commit does now the following. It forces first the write, second the flush, and third the server flush, which is different because now we have also the guarantee that even after the successful commit, if the power goes down on the server side, data is on hard disk. While without this commit, we have just the guarantee that when this DBR unlock was successful, if our workstation gets powered off, data is at least sent over to the server and therefore safe from a corruption by our workstation side. That's the big difference here, which costs performance. So in Clipper, there was no difference between this and that. And very often in Clipper, the pattern was used rlock, replace, db commit, DBR unlock, which in Xbase++ is generally slower because we strictly then send over the server flush, which invalidates a lot of more buffers and therefore needs more time to perform this operation. But this is not the reason why we have that performance degradation. What I'm referring about here is why we have the degradation in performance between here and here because there's a network in between and because we have this additional overhead of locking and rereading and flushing data. The problem here, it's quite different. Because until now we just talked about a table, which is not so real. Normally, what we have is, we have orders, we have index files. Unfortunately, index files are more complex. They are not like a PDF table or an ISAM, which means the table is a set of records. Each record can be independently manipulated. They're really independent. I can change 5 records from 5 different workstations at the same point in time because locks don't interfere. I can lock the record. While with the index file we have the situation, the index file is now simple, fixed size structure. It's a very complex graph, it's a tree. Huh? And data is not only on the leaves. No. Unfortunately, we need to visit data on the nodes too to get down to the leaf. So when I'm looking up some information in the index, I need to traverse the path. Even though when I'm moving from one record to another one, I need to traverse the path. That means it's not possible to have updating data in the index and allowing others to read data from the index because it's this complex structure. I mean, it's great because it means in a mathematical sense I have a degree of 3 or 4, I mean a deepness here, and then I need only 3 or 4 comparison operations to just find one record out of 100,000. Great, perfect structure for seeking. Very bad for updating, because, worst case scenario for updates, because when I'm updating an index, I need to remove the old key from the tree and insert the new key. Let's say I'm changing my name from Pirsig to Untitled, which means my name needs to be removed from the index with the record number, and the other name needs to be added to the index associated with that record number. And this means nodes and leaves need to be removed. It's a complex operation in this tree, which also means it's not possible that at the same point in time somebody traverses the tree because he could be at a subtree, which already gets disconnected from the whole tree when an update occurs, so the whole seek operation just crashes in the nowhere somewhere. So what we need to do whenever we access the index is we need to perform an exclusive lock, which means nobody can access the index at the same point in time. That's the bad news. That's the reason for that. That's why the more clients we have, the worse the performance gets. Because of that problem with indexes. Fortunately, there is since 1.9 something, which is called extended locking in Xbase++. When you enable this, then the performance, it means the previous performance gets dramatically increased. That's the case because normally it's so only exclusive locks are made by Clipper and Foxpro in these type of index files, which means a read blocks on the write, and writes do block writes, but also reads block reads, which is bad because reads don't need to block reads because they don't mutate the tree. So, I mean, multiple workstations could query or seek in the index at the same time without harm, but because of the roots of Clipper and Foxpro and the DOS environment, there was no technical ability to differentiate between a read lock and between a write lock. There was only the exclusive lock on the file system. And due to that, these systems didn't have it. We added this capability to the NDX database engines and differentiate between a read and a write lock, which means multiple seek operations can happen at the same point in time in the index file. Only writes get blocked by existing reads, or reads block writes. Because write is a mutation. I cannot move my slideshow forward here. I need to go here. I wanted to push the button here right now. So, oh no, we need to go back to transaction performance as well. And that's the great benefit of the ADS server, you know? Because the ADS server has the index in memory. He can organize access to this index in a more efficient manner because he's the only instance accessing that index. Which means there is no conflict with this read and writes from the client station because client stations don't log indexes. They just perform a C and the ADS server executes that specific operation. And so there is not this conflict. Because, to give you a number, in 1.9 the retry count to acquire that lock in Xbase++ was 100,000. This was since the early releases. And in 1.9 we increased it to 1 million. And why did we that? We did it because when client works in, let's say 15 clients compete over a CDX or NTX file of the index and compete about to acquire this lock. We had situations in average networks where 100,000 retries became normal. So, for your understanding, 15 user scenario today needs at least more than 100,000 tries to acquire a lock in a typical multi-user network scenario. Unbelievable. We are wasting energy, we are heating up rooms for nothing. That's the point here. Yeah, that's because there is no organization which controls success, and it's very unfair, that behavior, because the truth, it goes even further. Let's say we have an IT infrastructure with 15, 20 clients, where some of the clients are on the same switch as the server, others are in subnets, 300 meters or 500 meters cable in between, another switch, maybe a low-cost switch from targets. $25 including the muffins. Then what happens? The workstations new by the server have a very good chance to always acquire the lock of the index, and the workstations far away from the server have a lower probability to acquire the lock because their packets need to travel a longer distance. And this longer distance, it's unfair to them. The same happens when you have workstations in a network which are very different in means of performance characteristics. Old machine with very old hardware, very slow, and fast machines. If you are sharing files in the network, you need, because and you want to have a fair distribution of workload, you need to ensure that the clients are equal, they're identical, technically. Otherwise, there is this phenomenon. For example, there's a company and there's this guy which always comes at 7 o'clock in the morning. Anybody else in the administrative staff starts at 9. But this guy at 7 o'clock. He leaves the company at 8:45. Why? Because nobody else worked in the company. He was always the fastest one in the network. And the others needed to work from 8 to 8, whole day. It goes even further. There's that guy which comes at 8, not 7 o'clock, 8 o'clock. And he works at 9 when all others come in. And the others are coming in, start to work. But this guy, which started earlier, is still faster than the other ones. This is because of how Microsoft operating systems optimize work between, or optimize data access and data caching between client and servers. They prefer first, which means number one wins. Very unfair. So all that issues you don't have with the ADS, clear. It's a client server. You don't have that competition against locks. It also solves that problem. But it only resolves it after a certain amount of clients. SQL has an even lower transaction performance. We are talking here about transaction performance. Because there's even much more overhead. It's clear. There's an interesting rule you keep always in mind. Keep data as near as possible to your logic. What I mean is, it's clear. When my application runs on the local machine, it's the fastest way. But when you look at this, we have a network in between, and so we need to transport data over the wire. We can increase the performance of this scenario even without using ADS, very simple. We just use terminal server. We deploy our application on the terminal server and deploy our files on the local hard disk. No more latency, no more network issues, competition against logs happens again in memory, applications are far more faster, and I'm nearby there. Even better sometimes when I'm the only one using it because no network in between. It's like this. So using terminal server is a good idea to move my logic where the data is. Because my application gets executed on the terminal server, and on this machine my files reside. Perfect. That's exactly what ADS does. Because when I'm using the ADS server, I'm no more talking to a file server. I mean, I'm not opening files and I'm not saying seek to position and read this amount of byte. I'm talking to give me record number 5 or give me the next record, and if there's a filter, it does the filtering on the server side, not on the client side. No data travels from the record. So again, the ADS is performing better because he follows that rule. Data is where the logic is, the filter gets executed on the server, and because of that it's faster. This is transaction performance. Query performance we already talked a little bit about here in the context of the extended locking. Query performance can become much more better. Here it's the lower the better, not the higher the better. So you see, the query performance can dramatically increase when you are using extended logging because you reduce the amount of conflicts in the competition to acquire logs. Because at least in average applications, changing or updating records is an operation which is not done as often as reading records or performing query. Write is always less than 10% compared to read. Okay, and it's clear the ADS server, it's better because it doesn't need to send so much data over the wire. When we have a remote file, it always means when we just filter a table, that the whole table needs to be moved into the main memory, filters get evaluated record by record, and the decision is made on the client side if this record fulfills or does not fulfill the filter condition. Which means a lot of data is moved on the network for nothing. Which is not the case with the ADS because filters get executed on the server side, data does not need to travel, only the data we are interested in is moved. It goes even better with SQL because with ADS we're setting a filter and then we're asking for record by record by record. So that's the point where the LAN environment is okay, but in WAN environments it's getting bad because of these many request replies for each record navigation. With SQL we are asking for the result set, fulfilling the where condition in our select expression. So we get one request and get one reply, the complete result, which is even better when we talk about query performance. This is just some measurements which unfortunately you can't read. Okay, but if you can you read? Not so. It's just measurements we did about to compare extended and standard locking, Clipper 5.2 and ADS server with the Clipper client, RDD client, to remove Xbase out of this equation. And it shows very well the following. You can see here in this Clipper and Xbase standard locking, more or less the situation. We are starting here with 0.4, 0.12, and we are ending up with 5 workstations at 3.5 or 2.2, which is 10 times or 20 times. slower just because of these 5 workstations. When you look into the ADS server, we're starting with 0.08 and end up by 0.44, and this is not so dramatically. So we have a new bilinear increase, the same as when you look into this extended locking. It's starting with 0.41, 0.61, 0.113, 135, 17. It's more or less constant. It's not breaking away like this. And that's the benefit of having a server or the extended locking. The competition between read and write operation is no more that heavily than with the standard locking approach. Let's talk a little bit about patterns. Basically, when you're dealing with DBF tables or ISM tables in general, you have 2 approaches how to open and close, how to handle opening and closing of your tables. There are basically long living areas or short living areas, which means you're opening up your tables you need for your application when your application starts up, and you're closing your work areas, your tables, when your application shuts down. One approach. The other approach is you're using short-lived areas, which means when you're seeking for a customer, open table, seek, find, get data, close table. When you're updating the customer, open table, navigate to the primary key of the customer, perform your update, close it down. 2 approaches. Each of these approaches has its benefits, so to speak. The good thing is with the short-lived work areas, when I open and close them rapidly, that I don't need to care about network dropouts when my application works in a wireless LAN, for example, or for example hibernate issues when the workstation goes down and comes back. Why? Because when a work area is opened and the workstation performs hibernate or goes into a power sleep mode, the workstation is no more reacting to I'm alive signals coming from the file server. And if this happens, the file server then says, oops, this workstation is no more alive because it's sleeping. So I can shut down the resources I am holding for that workstation, which means server shutdowns file handle. Which means when the workstation comes back from hibernate or from sleep or from the power off state of the network card, then we're trying to work with file handle in our opened work area, which is no more valid because it's no more existing on the server side. Bad news, application crashes. I can test for that very easily. There's a DB info slot in the engines where you can ask to get the file handle for the work area when you're working with DBF tables and so on. And now you can do the trick that you use this file handle and use the fsize operation, the fsize function of Xbase++, which allows you to determine the file size. The idea is to try to verify if this file handle is still valid or not. Because by trying to acquire the size of the file using the file handle of the work area, we have 2 outcomes. First, we receive a size, or we get a file error which we can test with the ferror function. If this fails, we just enclose our work area, open it again, and anything is set. If this fails now, we know we have a size of file we don't need, but we know the file handle is valid and we can continue to work with our work area. So when you are using long-lived work areas for whatever reasons, use this to test. Why makes it sense to have long-living work areas? Because Microsoft operating systems generally, they have a lot of optimization strategies on the file system side, on the file server, but also on the quick relationship between file server and the client. Any of these parts of the infrastructure have heuristics inside the operating system which analyze how your application works with the file. And based on how your application works with this file, the operating system tries to optimize access for your file or tries to predict next operations to be more performant. Bad news is, when you are permanently open, closing your work areas for any operation, there is no history for file operations on that file handle. because the entire optimization strategy on the operating system is based on the file handle as the unit of work identification. That's why it makes sense to have long-living work areas, because then operating system, client and server can support you in means of performance. Otherwise not. That's simple, yeah?
Does ads have the same problem in a
No.
long-living area?
No, I don't think so, because the ADS server, in my understanding, holds the table open, the file handle open independent of the user operation from the client side. It's a encapsulation principle of the file server. If the file is open, it's on hard disk or even by 100% only in memory. That's a encapsulation principle of the file server, so I don't think ADS has an issue with that. He definitely may have some issues when it comes to efficient cache management or so, because any database server has that, but not in that context. On the other hand, when you have short-living work areas, for whatever reason you prefer to have them because of reliability or so, there is this problem that the Windows operating system has not only optimization strategies for a scenario where multiple clients access the same file, it's also a multi-level optimization strategy between client and server in means of, it's called opportunistic locking, for example, or OP break level locking, which means if you are the first workstation in a network which accesses a file, you are number one, and you're opening this file shared, the file server knows you are the only one who accesses this file. So even if you are asking to open the file shared, the file server considers that file as opened exclusive and tells the client to not send any update information back to the server. Instead, allows the client explicit to catch any updates on the client side, and also tries to move the entire file into a temporary space on the client workstation. This is an optimization strategy by Microsoft, which is preferably designed for Office documents, because I open them almost exclusive. Even I open them shared, so others can have a read operation on it. In fact, in 99.99%, there's only one user in a Word document. And because of that, it's a good idea to have it locally, it's faster and safe, and let the operating system decide when really the entire Word document gets saved back on the server. This is not transparent, not visible to me as a user. And this is the reason why we have situations that the first workstation in a network starts up and it's very fast. And then other workstations in the network open also the same tables, and the first workstation becomes very slow. This is because what happens in the first step, it's dramatically fast, because in fact, even though the table is shared, it's working like a local file because of this optimization. And when then another workstation opens this file shared on the server says, oops, I allowed one workstation already in the network to access that file and gave it the exclusive access. Now another one is using. Now the server does the heavy work. The server does send a so-called OP, opportunistic locking break level, to the client station, which forces the client to move back the file to the server, ensure any data is stored, and fall into this shared mode operation with the file. Because this is so much work and overhead for nothing, because we are always doing concurrent work, it's clear that having short-living work areas in your application, you are always competing with these useless optimization strategies with the operating system. So a simple trick to get rid of that crazy stuff is write a service in your network which runs 24 hours a day, 7 days a week, which just opens all your tables and indexes. It's easy, because then nobody gets an OP1 grant. And then it's always shared scenario, guaranteed the entire competition is history, and the entire crazy optimization will never happen. And it's easy to write that service. There's a simple solution to use a sample. So just take this service sample at the opening of all your tables, install it at one place which is up 24/7, like the file server if you can, and you won't have these issues anymore. Yeah.
But would this be also valid if it actually ran on the file server? It doesn't have to run on a client, this service?
The service can run on the server or on the client. It doesn't matter, but it needs to run 24/7.
Right.
Huh?
But it's not necessary with ADS.
No, it's not necessary with ADS if ADS is having the files locally. But if ADS, for example, is using the files in this shared mode, where Clipper or other applications can access the file directly on hard disk, and the ADS server uses the file in this compatible mode, not proprietary locking, then you're running into the same issues. So when I talk here about the ADS server, I'm only talking about this behavior pattern when we talk about proprietary locking mode. When we talk about ADS server in non-proprietary locking mode, it's a completely different story. It basically behaves such as multiple clients. There's not so much benefit of it.
We use proprietary.
You are using proprietary, it's clear. Yeah?
Quick follow-on on that. Are we talking about peer-to-peer Windows operating systems or a true Windows server?
Both kinds. Both kinds.
Both kinds.
We're calling about both kinds, but in general, we will not. How can I explain? We do not support the idea of having peer-to-peer networks because there's a lot of hidden other problems in these kind of application setups. We can talk about this later on.
That's fine. I'm just trying to get that.
So much about short and long living tables.
So the PostgreSQL will behave basically the same way the ads does.
Yes.
So we don't. This is not anything that we ever need to worry about.
Okay.
We don't need to worry about it.
If you move to this PostgreSQL server, no, you don't need to worry about this. You need to worry about the next. I told you yesterday or the day before, there's always a problem.
So, short question. Do I understand right? Are you saying that any time a workstation is going to sleep mode, the server cuts the handle of the open files?
Yes. I need to correct that to be exactly and precise. When we talk about Windows Server 2008 and the Windows 7 workstation, we need to correct that definition because the fact that file handles get shut down on the server side is a big issue in client-server systems, and so Microsoft decided that with all these mobility and so on, that they add a feature to Server 2008 and Windows 7, only in this combination it works. It's called long-living file handles, which means the server normally pings and sends out a question to all clients. This question is, are you alive? And clients normally respond with, I'm alive. And if clients do not respond, server shuts down resources. And with Windows 7 and Server 2008, server does not shut down resources, server does persist resources. And when the client comes back, because it's Windows 7, server can identify client for many reasons. When client comes back, server can re-identify client and can re-establish some, not all, of the shutdown and persistent resources, and so file handlers become long-living. It's a feature in this new operating systems. It's the only good feature SMG2 introduced, of course.
And that's the default behavior? Or is it something that we have to set?
No, that's the default behavior because Microsoft want to have it. Yeah.
Another short question about making this connection between server and client.
Yeah.
Is it always a whole connection, or can it be that only some file handles are cut?
Oh, that can be, but it's a little bit depending on the operating system version of your file server, to be fair, on which hard disk or on which it's called. There is a subsystem in the LAN server which is handling the file system driver and the real persistent data storage correlation. And exactly these different subsystems have different behaviors too. So the issue may become even more complex, but in general I would say it's very, very seldom what you described. His question was if it's possible that only 3 out of 5 file handles get lost. And my answer to him is yes, it's possible in some specific conditions, but it's extremely seldom.
I ask because I have to make the situation better. I have a thread which writes every 2 minutes from the client to the server 1 file and erases it.
You don't need to erase the file, you just need to perform an operation on the file server, just as open-close a file. But this only helps to avoid situations where, for example, a network connection goes down because of power-off energy-saving states. It does not help that your workstation goes down into a sleep or hibernate mode because of no user interacted with it. You cannot avoid that, unfortunately. You get it back in a few seconds. Okay, the other problem is when we have client servers that the connection to our server might get lost. And this is some issue you may have with ADS2. For example, you're working in a wireless LAN and you had a dropped connection, or you have lousy active components in your network which drops a lot of packets, and then for some period of time the connection the connection between the client and the server gets lost, the I'm alive message is not sent, and so ADS shuts down resources. Can happen too. So it's always a good idea to verify if to find a way to verify if a connection is still valid or not. I don't know if there's a functionality in the ADS server. We at least did add some functionality for the Postgres and moved it into the isConnection method of a session, which means with the Postgres SQL server, isConnect is guaranteed to work properly. What it did is, if you are executing isConnected as a method, it tries to send a ping to the server, and if it receives an echo from the server, it's a proof that the connection is valid, and so isConnected state is definitively true. So you can verify it.
Well, is connected a method in the DAC session on it?
Yeah, it is.
And
And
so
that's a DAC session.
And adds a DAC session, so shouldn't we be able to do that?
Maybe, but we needed to add a special code to make this happen, because the problem is that ADS2 uses these TCP/IP sockets, and sockets by definition are not reliable. So because of the fact that sockets are by definition not reliable, there is no functionality to verify if it's connected or not in this simple view. One word to connections. First, connections encapsulate transaction contexts. That means if you are using a connection to different threads, you are definitively doing something wrong if you are using these connections to do operations against the same server, which is the same connection. Why? Because if a connection encapsulates transactions, then I have thread 1, which does some changes with this connection, and the same connection is used on thread 2 to perform some operations, and then thread 1 performs a rollback. Then it ensures that all operations against the database are rolled back, so never done. But because the same session was used by the other thread, the same connection, oops, all the data changes by the other thread are also rolled back because sessions encapsulate the transaction. They define the transaction context. Okay, so one session, one connection per thread, please. Otherwise, deep trouble. Very important. Otherwise, you're basically losing control. With the ADS, it goes even further because he's very sensitive to receive operations from different threads through the same connection. We need to add special code in the database engine to protect ADS from this. So if you're using additional languages beyond Xbase++ when doing ADS operations, you need to avoid this definitively, because you have special protections in Xbase++ against this. ADS does not like definitively does not like to get requests from different threads over the same session or connection.
Oh, we've been doing this.
We've been doing this all the time.
We've been doing this forever.
Well, yes, and that's why we added special code to the ADS database engine, which in fact ensures that all your operations get internally automatically serialized from the DBE to the server, because the server has problem with that.
Okay, so then we don't have to change.
You need to change because of the transactions. And you need to change because it's more performing, it's faster.
It's faster?
And I think it's a good idea.
Oh, I thought the other way was faster.
No,
That's
no,
why
no,
we
no,
did
no.
that.
No,
Okay.
no, it's definitively the case when we talk about client-server. Independent if it's SQL, Postgres, ADS, even if you write your own server in Xbase++, an application server with proprietary protocol, don't share connections, because, think about it, when you send a request to a server, what's most of the time the case? Most of the time you're waiting for the answer. So if you have multiple threads, where each thread shares the same connection, these threads are waiting for answers in a serialized manner. So only thread 2 can receive the answer when thread 1 has received the answer, because they're queued up. But if you have multiple connections, each thread can send the question to the server independently. Server can calculate the answer independently because it's a server, and send back the answer much more faster. So having connections, one connection per thread is faster, safer, better. It's golden rule.
Something.
Yeah.
That we have to rewrite a lot of code.
No, we don't.
Yeah.
We don't have to write it.
But that's not so
It's
much.
just one place.
One place, don't worry. Let's talk a little bit about conventions. My session is finished at 12:30, right?
Yeah.
Okay. Let's talk a little bit about coding conventions. Use camel case for functions, methods, and variables. Clear? It's clear. Camel case is like this word written, camel case. So my function, uppercase M, my lowercase f for function, uppercase, function. That's camel case. It's clear what I mean with camel case R. Now it starts to become interesting. Use Untitled notation only for variables inside the body of your method, function, procedure, wherever. Never ever use Untitled notation, which means you put an uppercase letter for the data type or class in front of your variable name, for example, for member variables of your classes. If you do that, you are doing the biggest mistake of your life, I guarantee you, for a simple reason, because you're breaking the basic idea of object orientation. Yeah, object orientation is about encapsulation. And when you design a class consists of two important aspects. One is the class concrete implementation, which knows about data structures and all these details, how it's implemented. And then there is the interface of the class, the part which is exported. This is the part which others use. And you know, this is used all over your application. And when you have written hundreds of thousands of lines of code, you know, only the exported interfaces are used in my code. Anything else which is protected, it's only used inside this class and derived classes. And when I declare it hidden, I know exactly this is used only on this class, not even on derived classes in the implementation. Getting back to naming convention. Let's assume I have a variable which uses Untitled notation. Then this member variable documents some implementation detail. For example, the A prefix says, okay, the data, the collection of this class stores the information in an array. But somebody using this class, for example, our customers class, he's not caring if it's an array or not inside our customers class. I want to get a group of customers, and if it's stored inside an array or in a tree or whatever, I don't want to care. If you want to expose an array from your class, then name the method this way. Get data as array. That's correct. Because then anybody knows, anybody has the interface which clearly says, I get the data as an array, but don't have a memory variable which is declared a data. Because you never can change the implementation detail on your class without breaking with all your conventions. So the big point here is that you need to think that in two areas all the time when you design classes. There's your implementation, which is what you're concretely implementing to make that feature real. And then there's the interface, that's what others use. And interfaces ideally are never changed. You will find this in APIs. There is the XYZ API, and then there's the XYZ EX API. And that has a good reason, or version 1, version 2 of this method. Why? Because if you have implemented a method on your class, you don't want to change the parameter profile or the behavior of that method. Because if you do change it, you need to verify all your other code about usage of this method. You're running crazy. You're finally degrading your performance as a developer over time, basically this way, because the amount of code you wrote is getting larger. Therefore, the amount of code you need to review all the time is always getting bigger and bigger. And you're losing money for doing nothing. Use the methods, do the abstraction, create another interface, leave the other one as it was. And that's, again, another important part why implementation and interface are two different things. That's object orientation. It's not putting anything into classes. This is not object orientation. This is done by many developers on that planet, but it's not related to OOP. Okay, so now more implementation for members. You can use names. Very often, why should I? We have a class customer, for example. And this class has a member, C last name. I mean, this is more than crazy. Because anybody on this planet knows that customer names are in characters. So again, there is no need to have member notation. Member variables have to be clearly in their naming about their content. That's it. And you can do that, you just need to think. Don't follow this old rules. They have been very old and they have been thrown into the garbage can since years. Next question. Can you read this? I have here a select statement here. Here's anything related to fields and alias names uppercase. Here's lowercase. Who likes to prefer the lowercase variant? Raise hands. And that's what I feel. Okay. And who likes to prefer the uppercase variant? So what do I feel? Oh, much more. I'm sorry to say, uppercase is wrong. Yeah. If you go back 10 years, I would have agreed with you, uppercase makes sense, but we need to use lowercase, and there are two important reasons for that. First reason is, when we talk about client-server and SQL systems, some SQL systems are case sensitive. That means you can have in your table a field last name uppercase L and a field last name lowercase l. It's different fields. It's very bad and weird. First problem. It goes even further. If you then want to write a select statement in some of these SQL systems where you write the fields, if they're in this mixed case, for example, camel case style or so uppercase style, you need to write field names in select statements in single quotes. Or in Microsoft SQL Server, you need to write them in brackets. So you finally have writing here open bracket, open closing bracket. Are we running crazy?
Yeah.
No. And the final point why lowercase is better is because by definition we already write all the commands uppercase, you remember? And because with SQL we have complex statements and there are a lot of language constructs inside, it's much more clear to read to have it lowercase than uppercase. So again, breaking rules is a good thing, but you need to have at least 2 reasons. We found 2 very good reasons, of course. So we're here with officially breaking the rule of the last 2 decades. We are moving to lowercase, please. Because it's better readable, less trouble with DBMS systems. Okay?
So the alias in it too.
See, I've always used the alias in uppercase,
Yeah.
the field in lowercase. That's the way I've always
Yeah,
did it.
me either, but things changed over time
I know,
and you need
yeah.
to rethink, and
Yeah.
so we rethought and we finally concluded.
Okay.
I see no reason for using uppercase for the statements as well.
Huh?
I mean, I see no reason for using uppercase for the statements as well.
Because it's a language construct that makes it generally more readable, and because we want to have a differentiation between them.
Either I've got color coded.
Yes, definitely.
You have.
Yes, but then the big question is, are we writing the U's and all the other kinds
Yes, all-
lowercase
all
too?
lowercase,
And no. Here we stayed with the uppercase because any other parts of the language, such as if, else, and if, are also uppercase.
All lowercase.
You're all writing low. No. I want to have the. We looked into this and we compared different things, and then we studied the coding conventions of other languages. And we followed here the basic idea that language constructs and syntactical elementary constructs are always uppercase, and therefore sprang into this because code is still printed out, and because not always syntax highlighting is visible. So it's, for example, when you do a diff in CVS or a version control system, you don't have the syntax highlighting support basically. So it's yeah. So there are many good reasons to stay with uppercase for these language elements. At least that's what we concluded after reviewing this. We haven't finished it, but we worked on a coding standard for Xbase 2.0. It's a lot of work because we wanted to do it in a, as always, pro way. So we analyzed a lot of other languages and coding standards and how coding standards have evolved in the last decades. There are many papers on this. Unbelievable. Okay, so much about conventions. So we use lowercase for our fields and aliases. We write the commands uppercase, which of you don't like. And the good thing with coding standards is, if you, Peter, for example, or you, Norman, if you like to write your commands lowercase, it's totally okay. It's your decision. Huh? There are things you can't break in coding standards because you have good reasons. A coding standard or convention should never be taken as some rule. If you don't follow, then you get killed, except what I said before, using Untitled notation in exported memo bars, because that's not only a simple coding standard. We are here talking about elementary principle in object-oriented programming, basically the idea of object-oriented programming, and defines uppercase too. I have here a simple data model. Good. Oops. Let's ignore these related tables here. It's just about demographical information of our customer. Here on the left, I have a customer table with a primary key, customer ID, company name, contact title, address, city, region, postal code, country, phone, and fax numbers. And I would like to ask you what's wrong with this customer table. So what would you change? What do you think is wrong with that customer table?
Take the contacts out.
Okay, number one, yes, I agree. Take the context out.
What does that say at the top of the table? Data what?
Data model.
Data what? Oh, there.
Okay, first thing which is wrong is that the contact is inside the customer, because customers may have multiple contacts, so it makes no sense to have one. And it would be a very bad idea to add contact 1 name, contact 2 name, or contact name 1, contact name 2, contact name 3 to this table, because then we have these tables with hundreds of fields, which make really no sense. No. We can use another table just for the contact and establish a one-to-end relation. But what else is wrong?
I can't see the
I
names very well.
can't see it, Stefan.
That's why it's not so obvious.
Could those
See, the
lights
names
over
are
the
kind of
screen
hard
be
to
turned
see.
off?
Huh?
No, I can see it.
I don't know if the lights that are right over top of the screen.
Yeah, the lights are making it bad too.
I
And
think that's
how?
what the problem is.
I don't know if
Do
it's.
you have some gun? I mean, I can try.
It's okay.
Oh, fire alarm. How about this?
That'll solve
Okay, that's not.
it. Switches.
That's okay.
Maybe. But that's my last try, and then we gave up on that. Here are some buttons. Maybe that's it. He's trying to push any button, and then we'll see what will happen.
Yeah. Wow, better.
And that's new by the end of the session. We are so taken through. Okay. Okay, folks. Some other idea. I mean, Peter already mentioned that having the contact with the customer's table is a bad idea. Something else? I would say, what about the phone and the fax number? I mean, today we have mobile phones, so at least you have a lot of numbers. You have primary, secondary phone number. It's also a good place for having another table. The case I want to make here is that you always you should have more than one table. Don't have these tables with multiple contacts in, tens of phones in, and so on. Even with the Xbase++, it's a good idea to have more tables compared to just one table, which is large. Why? Because working with multiple tables, it's more efficient. You can have more records in memory. The reader head characteristics, the caching is local to your work area. So if the record size is 500 bytes, you can cache 50 records, 100 records. If the record size is just 100 bytes, you can cache 1000 records, for example. Or the engine does cache that amount for you. And when you set relation, when you navigate on the primary table, nothing happens on the child tables, not even an operation on the network. Only when you access fields on the child table in a set relation to command, then the child table navigates according to the requests on the primary table. What Xbase++ does internally always is, when you navigate on the parent, it just creates navigation requests for child, which gets queued up on the child side. And then the first time when you access data on the child paratable, or try to access the record number or EOF state, then all these queued up navigational requests get consolidated and performed into one operation. So it's very efficient.
But what about overhead with opening like 100 tables as opposed to opening 50?
Well, it now starts to begin, because when you have, let's say, those many tables and you are permanently opening and closing your tables, then you have a lot of resources you require when you are open up and closing. That's why it makes a lot of sense and used in the long-living work area scenario. You're right, it makes no sense when you have just for a short time opened your table in your application. But I'm now talking about client-server and SQL. In SQL I have this ability to create views. So the entire story becomes different, because now I can normalize my table and can have 1, 2, 3, 4 different tables, but I can create a view which is just a artificial description of a select, which I later on use in my select or even in a use statement. And this way, in my application, I even don't need to deal with this multiple table issue, because I'm accessing the view for my data. So the case, again, I want to make here is rethink over time your table structures and try to get rid of that mammoth tables with that many fields, that many redundant fields. We see it a lot in tech support. There are some reasons, there are historical reasons in these applications, because customer always had 20 years ago just one phone, and then they bought a fax machine, so we added the fax field, and a couple of years later they bought the first cell phone, so we had the cell phone field, and so on. But rethink your table structures and try to split them up over time, at least for new applications to develop. Yeah?
But for performance reasons,
Yeah.
let's take this SQL table first.
Uh-huh.
So I'm going to do select statement, and I'm going to get a view of customer data. And I want the customer's name, which is fine.
Mm-hmm.
Customer's address, which I have a separate database for, because it could be an
Table.
address, home address, business address, something else.
Mm-hmm.
So then I also have the contact information, and I have the telephone information, which is all now 4 separate tables. I'm creating that view.
Uh-huh.
But what about resource or seek time? Because as I grab this customer, now I gotta seek into these other databases to grab, to add to the view. Aren't I
Don't
decreasing
care
my
about it.
performance?
Don't care about it. Exactly, that's why SQL servers are designed how they are designed. They are designed to serve exactly that purpose, to have as much as small different tables correlating with each other. That's how they are designed. So the entire storage system, the entire data access, patterns, mechanisms, optimization strategies are not designed to manage efficiently tables with hundreds of columns. They are very efficiently designed to serve small tables which are correlated to others, because that's the whole theory about this thing. So we're talking here about some difference. It means of general view, and SQL systems are designed to deal with this type of data model.
Okay, so second question. Let's move over to the ISAM side for a second.
Mm-hmm.
Now I wanted to do a browse. I'm going to access 4 different tables to create my browse.
Mm-hmm.
Does it make more sense for me to do in my columns a DB seek into each thing, or to set or set relation to?
No. When you have normalized, when you have a data model which is normalized this way, then it makes a lot of sense to create a view, and then to use the Postgres ISAM feature against this view, so to speak. Yeah? Because you can query the result set of that view, and you can browse into that view, and then the server already aggregates all the data from the different tables and creates exactly what you want to see. So it's perfectly for you. You don't need to deal on the client side with that type of information processing, so to speak. It's faster, definitively. And again, when you think you want to have redundancy in your tables, even so normal forms clearly state you are not allowed to have that, go for it if you find reasons. And that's again the bottom line. If you have at least 2 reasons to break a rule in the 3rd or 4th normal form when you're creating your data model, go for it, do it. But please have 2 reasons, not just 1. I mean, think about it. Okay. Ooh. You know, we have these work areas in Xbase or in Xbase systems in general. In Xbase we have in addition the Workspace, which is the collection of all work areas of my thread. In 2.0, there is the concept of named workspace, which means I can have multiple workspaces which have a name, and they can be associated to a thread. So in 1.9, it was the case that there's only one workspace per thread. In 2.0, you can have infinite workspaces per thread, but they have a name, and you can grab them by name. In other words, a workspace now correlates to a database. In other languages, there are class frameworks such as ADO, T-Data, Set, T-Query, whatever. There are object relational mappers, which are tools which are let run against the data model. Then it generates a lot of classes which basically wrap all my data access and allow me to have an object-oriented, now syntactically object-oriented way to deal with data. There's LinkU, there's Pojo, there's MVC. This all is patterns. These are methodologies how to deal with data. But they all have one thing in common. For all languages except database languages or languages such as Xbase language, they just they need to deal with something which is called impedance mismatch, which means the languages have no idea about nil or null, which is a special state of variable. It means unknown, no data, unknown data. I know nothing about. There's no data. This is important in SQL systems because it's a special state. Non-programming languages have no idea about that. It goes further about, what about empty data? What's an empty string? What's empty date? Other systems have no idea how to differentiate between this. There are tricks to emulate and simulate, but all this, these basic differences between data, database systems and how the language is. For example, when you talk about values, numerics, for example, when you talk about behavior of a numeric and a double, just one case, this all is called impedance mismatch. The mismatch between the database and between the programming language.
What's that first word you said?
Impedance. Impedance mismatch, that's the technical term for this problem. And all these frameworks are just dealing with that. That's their major purpose. Because the Xbase language always is coming from the data side, restricted to ISAM until now. Now with SQL, we don't need to deal with that. We don't need to care about impedance mismatch. So the point I want to make here is we can get rid of the ideas of class frameworks encapsulating something such as a work area. Because, okay, some people, they create code or create classes which encapsulate, for example, the customer table, customer class. And they do that because what they did before, they lost track. What they did is they used the work area, customer, and they assumed state about the work area in their application code, such as this record, this folder, or whatever. So they assumed the state about the work area. And this is golden rule. Never assume a state about your work area. Your work area is this table you have available, and you want to do something, then seek, find, update, or perform the operation, but don't assume a state. If you want to get back, remind the record number, remind the primary key of the data you are working with, but do not assume a state. If you do so, you will fail over time because applications get complex more and more over time, and you will lose control. And that's the primary motivation, what people did. They assumed state about the work area. And because of this assumption, over time, applications they lost track in their code about the states of this work area. And so they tried, I need to resolve that. What they did is they packaged now the work area into a class. But this is just a workaround for the primary problem.
No,
That's the key thing you need to understand, yeah?
No, it isn't. I do just that, but
Yeah.
it's not assuming a state. It's also assuming whether a file is open, yes or no. A table is opened, yes or no.
Again?
It's not just assuming a state, it's also assuming whether a table is open, yes or no.
Yeah. But when we think about tables as a database, then the table is open because you perform the connection and the table is always available. And that's why the preferred way to work with tables is to have them long-lived open. So in general, because it's very identical to the semantics of a database. When you connect to a DBMS server, then after the successful connections, all the tables are available to you.
Yes, but if you want to port your code from ordinary DBF tables to a SQL server,
Mm-hmm.
and you want to prepare for that, then it's easier to do that with a class framework.
Yes, you could do that if you like, but I'm not talking about migrating of your old code. I mean, this is your personal decision. I'm right now talking here about the fact when somebody uses classes to wrap this. If you decided to wrap your data access into these classes, your decision. If you feel comfortable with it, your decision. But this is a specific use case. You want to access, you want to isolate the data access in an even more abstract manner because, for example, we want to have access to Microsoft SQL, Oracle, and others. Your decision. But again, I disagree a little bit about this idea of tables, but we came to this again a little bit later, or not. We need to talk separately about it because of the time slots. But, okay, again, people start to create classes which are simple wrappers with navigational operations for a work area just because they lost track about state of work areas. That's the key point. There are the reasons. In Xbase++, and when you think about a little bit more about the capabilities with 2.0 and Universal SQL, when you just open up database and you have available all the tables and you can check for availability of the tables, there is no need to wrap this into classes, except your case, if you will find a way to transport data from your databases through different layers. And now we come back to your point, because another major purpose of all these frameworks on this planet, of these big and large frameworks of this planet, is to enable transportation of the data from the database to the UI finally. There's another problem, because developers, when they are coming from university, they are not so well trained in means of databases. They don't like databases, not fancy. They want to deal with cool languages, great fancy graphics, at best a computer game with some cool sound. Developers are developers. And programming language developers, they don't like to deal with data. They don't like to deal with databases. That's a big problem today. And that's why, for example, all these object relational mappers exist, because the people have no idea how to write a select, but they know that they can execute get customer by name method on this class. The big problem, on the other hand, with this ORM mappers or entity framework and .NET is that there are a couple of issues with them. First, they're violating the traditional data access isolation semantics. For example, let's assume I have this object which is from the database and the entity framework and the relational wrapper automatically synchronizes my object with my table. But what if this object is used from different sites? Who controls congruency now? Well, the congruency against my data is following the semantic definition of my language, of my programming language, which is a very bad idea, because data already has from the database a clear definition of congruency behavior. Right? So there's the first conflict here. The other conflict is that these relational mappers are always static typed. So when you change the schema of your database, you add a field or you change the length of a char field, then you need to go back to the generator tool, regenerate the complete framework, recompile your application, and you're all set. So that means minimalistic schema changes need always rebuild, recompile of a framework. I've maybe customized that framework, so the customizing needs to apply it with refactoring tools again to the generated code of the ORM system, and it continues. It's a lot of work just for maintenance purpose for nothing, where normal developers don't care. Normal developers, database developers normally don't care about it because they know applications need to follow the schema. This is an abstract view of an application. And when we look into this, there's down here the data access type, which means I'm performing here my operations such as selects against a SQL source, my ESAM operations such as seek and so on. That's where I'm living here. And then I have my business logic and my rules enforcement, which means I'm checking if I can deliver this order, is there enough stock or things like that. And then there is the data model and my basic validation, which means is it allowed that a customer has an age of -5? It's not possible. The age of a person is positive and in most of the cases lower than 1000. So there are different abstract types in our applications. Generally you can separate your application in these 4 different layers. It's the user interface, the data models and the basic validation. It's your business logic and the business rules enforcement and the workflow partially. And it's your data access type. And normally you need to transport data between these levels. For this we use, when we handle the data access, we write with fields and work errors, clearly. But then we need to transport this data from our data access layer down up to the business logic. For this we use objects, arrays, statics, parameters, whatever, privates, publics, the whole feature set of language. And then there's the business logic, and we need to transport it to the buffers of the user interface, where it's an array for browse, or where it's a collection of values in an array which is bound to the UI. But then we need to have some validation, because we want to have in the UI validation. Then we have the problem of observation, which means I have a value in the field 1, in the entry field 1. When I enter some value here, another calculated value on the output view needs to adapt to this change. That's an observation protocol. All this needs to be done on this level. And again, we bind it to the user interface using objects, arrays, privates, publics, whatever we have in our purpose. When you look into well-designed applications, I mean, in the context of Xbase++, for example, then you will find that people not only started to layer their applications more or less in those 4 tiers, they also started to consolidate this, because they tried to find a way to efficiently transport data without dependency to the work area. So to transport data independent of the work area, which is our data access tier, transport data efficiently through these layers. And so they created, for example, classes which are reflecting the customer table. But then they realized, oh my gosh, I'm running crazy with that. Because what they finally end up is, they're writing a bunch of code because they need to maintain always these classes for all these different tables. They have hundreds of tables in their system, and they change something, they need to add members, remove members. It's a lot of maintenance work, and then they added functionality to these classes, such as business logic method. Wrong. The point is, first of all, the class which has the values for which transports the data never is allowed to have business logics or any type of functionality. It's a dump container, not more, not less. Java people name it POJO, plain old Java object. It's a technical term. When you look into books about enterprise application development and patterns, it's called DTOs, data transfer objects. So keep in mind, these type of objects which transport the data are dumb. They have no functionality associated. It's in your customer manager class. The customer manager class implements business logic. That's here, for example. and it returns depending on the interface or leads management class, which both finally came down to the same tables in one way or another because it's different state of the contact and the address. The leads management class and the customer management class, those can return customer or contact objects with totally different members, reflecting the different data required for this different domain I'm using my data. Because we're now talking about business logic. And that's why it's a very bad idea to have the class, which is holding the data, and functionally in the same class there's a customer manager, and there is this contact object, which is the dump data object, so to speak. And this is free. This is not depending on work areas, whatever here and there. This is a dump data object. No dependency on anything is allowed, because only then you can move it between your tires freely up and down. Huh? We have some customers which already do this. They have wonderful large applications, very well designed, according to, let's say, latest design standards in enterprise application architectures. And what they do is, for example, they then use the no-evar, set-get no-evar mechanism to create that dynamic object, because this way they can have a dump container to which they add it. The problem is, with the set no-evar stuff, it's way too slow. And it breaks some rules of object orientation. And that's why we created data objects in 2.0. Because what we want you in the future to write applications this way. And now we are back to your question.
Yes.
Huh? Because we want you to have your data acceptor and to use fields and work areas with select, universal select, and unified select, and whatever you want. But then it ends. You have your data objects here. And here you create your rules which are using these interfaces, and then you return here only your data objects.
I've only got one comment.
Huh?
I've only got one comment.
Yeah.
You're late.
You can try it out right now. So we created these data objects because we wanted to have a very efficient solution for this problem. So we are not late because you can use them. To talk about matrix. Just look at this. When I'm accessing in a for loop a local variable, a numeric type, I'm just reading the numeric. I can access this local variable 40,000 times per millisecond, which means I can read the local variable on Xbase++ on my laptop around 41 million times per second. 41 million times per second. But when I'm using the no-evar mechanism on an object, which is this, I can only access it 1,538 times per millisecond, which is 1.5 million per second. Which means we are going down from 41 million to 1.5 million no-evar, but it goes worse, even worse, because this is only the no-evar mechanism. To make it real, we need to store the symbols for our evars we are emulating with this mechanism, and we normally do it, we store them in an array, and we use, for example, a scan or something like that to send them back. And then we end up here. We're ending up at, we are able to have 27,000 accesses to this type of dynamic members per second, which sounds very much, but it's not that much because 27,000 is way too long. With data objects, you are back at 2.7 million per second. So we're by 100 times faster at minimum. But we give you even more because this conference build, you can, on any object, if it's dynamic or it's static, means of compile time, you can use the index operator. And don't mix this up with arrays. Arrays are data structures, objects are data structures. The index operator works on objects now, on strings, numerics, and arrays. numeric array strings, it always worked. We extended in 2.08 for the objects. What you can do now is you can go through all exported members of a class, and there's no difference between dynamic and static members, and access them using the index. And this is genius-like, because now, not genius, this is very convenient, because now that means when you want to move data from, let's say, your work area to the object, you don't need to use the name of a field and do the macro evaluation to put the data into the object, for example. Now you can use a for loop, an index, and it's 7.6 million per second. So we are now 300-400 times faster than before. And that's the cool thing why we think you need, at least your code in the future, use data objects as the universal transporter between these layers, because there will be more with data objects. We want to have data objects to migrate over time to become not only dump data containers, but also what we call smart data containers. When you think about UI, the UI needs the data to be visualized, but UI needs exactly two little things in addition. It's simple validation rules such as required, not required, and observation, which means this field changed, which means the resulting calculated field must change too. There's a dependency between values. And exact that type of dependency and functionality, basic simple validation and observation, will become a feature of data objects too, but, and that's a cool thing, you can add it today by adding the method, with the ability to automatically expose it in JavaScript. That means you have, and now we're back to CXP. That means you transport the data object through your layers. You define your expressions in Xbase++ for validation. You define the observation dependency. And when you hand over the data object to a JavaScript system, the JSON export of a data object automatically generates JavaScript code, including for the validation observation pattern. We're in a perfect world now. Got it? And that's why CXP is there, because we need to have the view part. Because we are basically, with CXP, we're doing the view part on this side. And with the SQL stuff, we're doing the data access part. And data objects will bring these worlds together. And I'm pretty sure in some time frame, we will have a nearby perfect world for applications which can have a Windows 32-bit UI, a web UI, or whatever you want, which can even become distributed, because, you know, the great thing with the data object is it's independent. It's just a dump data container. So we can move into an XML representation, send it over a web service, and on the other side, use it from other languages or compose it back into a data object. So we also have distributed applications. So wonderful world. And with that, I want to close this session, and unfortunately, your questions. But I can't start without thank you. You know, but you get now the idea.
Yeah. Nice, very nice.
The point is, it was a long track. We designed this data access chain, remember?
Yeah.
And we even implemented data access chain.
Yeah.
And it was 2 years ago, we had it finished, and this was a great poster.
Yeah. I still got the PDF.
Yeah, a great poster, but then we realized this is wrong, because it's exactly the mess all the other companies are doing right now. And so we moved forward and rethought our decisions about that. And so we came to this, and this is the best thing I've ever seen in all languages on the planet. Do you agree?
Yeah. How do you extract it on the data? How do you get at the data in the data object?
By the name of the member bar?
So you do colon, the name of the field?
Yeah. No. When you look at this, it's here. We have here the data object. It's a class. And the first big thing is because data objects can learn member variables by assignment. I mean, in this line, the data object has no member variable, okay? But when I assign a value via the name of the member to it, it automatically learns that member name. After this point, you can use, for example, here is member var, and it returns that name. Huh?
So the name can be the field name.
That's exactly the point. It must not be, but it can be the field name. Exactly. You have a universal transporter for your data. That's the key message. And then here, this is mandatory. You need to pass a name. Why? Because with data objects, you have object instances with different members of the same class. And there needs to be an additional naming scheme on top of class. And so the class name became the namespace, which when I execute, you see here, that's data object and then namespace operator. And this is the concrete name of this instance, which means customer, for example. That would be a correct naming scheme. Not the concrete customer such as customer number 500. That would be wrong. Yeah. But customer, data object, data customer. And so I can very easily add the members. It's completely added to the reflection of the system. So when you use isMemberVar, or if you use class describe, it returns the members you dynamically added. And it goes even further. The performance after this point in time is definitively the same performance such as a native member you declared statically, because we are at runtime dynamically cheating the native code for the member access. That's why this great performance is here. Because you can't reach that performance level with simple creating hash tables and dynamic characteristics. You need to create a dynamic into native code at runtime. And I can create subclasses from data objects like this. MyDO, it's here MyDO from data object, which adds a method and so on. And when you look at the output, here MyDO.savings, because savings was the parameter I passed it here. And
I haven't seen it, but this is all documented. There's
yeah,
help files.
it's in the conference build.
Yes.
It's only partially documented, but you can try it out. And I will download this file to the server this afternoon with the other samples.
Yeah.
Any sample, any code we showed you on this conference, I mean Alaska, is working with the conference build, no exception. Any samples, because we are using only the conference build.
So this is just a compliment. And he's right, because with the record objects, the speed is phenomenal.
Scheiße. And the session right after this.
What's this? Photo session.
Which one?
No, Advanced SQL is my next session right after this.
Advanced SQL, you said?
Yeah.
Is it in German or?
Yeah, unfortunately it's in German, because if it would be in English I would make a party. But in German I have no slides.
You have no slides?
Yeah.
That's why you came down so fast, because you didn't finish your slides last night? Is that why?
Yeah.
So that's okay, wait it, you're good.
Deutsch. Nein, das kann ich nicht. Ich habe ja auch keine englische Slides. Tolle Idee.
The advanced SQL in English is tomorrow.
Yeah, but the German one is right after the dinner, and I need to create something. Oh, scheiße.
Okay. No rest for the weary.
Does that mean you find yourself
So
an
what
excuse
gonna-
not to get on the photo session?
No, the photo I'm on. But now you get the idea
Yes,
what
yes,
we did.
yes.
And I think it's a very elegant solution
yeah.
where because it resolves on each layer this problem very well.
Then I'm glad I didn't get the data access chain objects.
Yeah.
But I've been designing a lot of
You
this
see,
now
when
myself.
I finished it, we realized it's wrong. We did some implementation of applications and asked ourselves, what's the real benefit of having this? because we did it just because anybody else did it.
Well, that's his English
And
class.
then we tried to create many different types of orders and try to find out how to make it better. And the first step was that we realized that we need to have this relational capability on the language level for any data type. Because then with the data objects and the select statement that you can create very efficiently.
I'd love to get that OTXP on the
And that's the connection to the
That's what I wanted for.
CHP.
Everything else.
Just
Now that makes sense as well, yeah.
But, yeah.
And we already have the controller and model execution environment. We don't have it, our entire infrastructure runs with them already. But we don't have it documented, we don't put it into 2.0. But by the end of the year, there will maybe some post-release of this stuff that people can use the CXP, MVC.
They can give me that enough
only a few and MVC anymore. That's better.
Transparent browsers.
Okay.